forgotten to remind me about the record.
Don't mind me, Jerry.
It's normal, Jerry. Even me, say me if I forget. Okay. I'm going to pick a beam that will look a bit similar to that. Let's say I pick this beam. This is an existing drawing. Okay, you know, I told you to make your work easier and faster is good. You just have an existing drawing, or else you are going to spend forever to achieve detailing in AutoCAD. I'm telling you, you are going to spend forever before you can. But I'm going to be showing you some of these beams. Let's say this beam, you can see this beam 5, beam 6, they are all in like the same shape, even though they are not the same beam actually, but although we have some of them are similar. This is beam 6, 6, 6. All these three are the same beams. This is also the same. So I'm just going to just pick some few, maybe like 2 to detail. This beam now, if you can see this span here, 1,230. This span here is 4 meters, okay? So, but you can see this one I picked, which is the existing one. Let me take the measurements here. I'm going to rescale it back to its original scale. You can see here it's telling me 538. And I know that this span here is supposed to be 230, which is the size of the column. Don't worry, I'm going to explain all that to you. Let me just rescale this first. This span here is 200, it's supposed to be 2,100. So this is supposed to be 230. So I'm going to rescale this, SC, enter, and then I will highlight, and then I will drag, I will type in 538 divided by 230. I hope I'm correct. Does it make it bigger or smaller? Bigger. Sorry, it's supposed to be the other way around. SC 230 divided by 538. So it will be 230 divided by 538. I usually normally is to forget this, but once I try the other way around, I'll get it. It's something I normally forget all the time, but that's it. So that's how to rescale this. So we've gotten the original scale now. Now, if you take this measurement, you are supposed to get 210. Okay, you can see it's very, very close, just 1 mm difference. But let me check here. Sometimes it could be the drawing itself that has that problem. Okay, but I can still rescale it just to get it exactly at the way I want it. So I'll type 210 divided by 2101. Okay. Aha, perfect. Are you still with me?
I'm with you. I'm with you.
Okay. I see that you are quiet. So
okay, I'm with
now it's perfectly okay.
So you are rescaling the object.
Yes, to its original scale. You know, they actually blew this one to look bigger so that by the time you are printing it, it will come out well. That's why it was rescaled and it was made to look very big. Okay. So that when you are printing, it will come out very well. So that's why that was actually rescaled. But now,
okay. So, Mr. Hello, Mr. Abel.
Yeah, I'm with you.
By the time we are done with this training, there's still one other thing I would like you to take me in.
What's that?
Is on AutoCAD training anyway, but not like the entire AutoCAD. I want you to take me training in how to print, set up printing, set up a page, scaling, and the concept of annotations, scaling of annotations,
No
scaling
problem.
generally, and printing.
Okay.
Okay.
No problem. No problem. Let's
All
go
right.
on. Let's go on detailing and finish it first. Let me
Okay, boss.
let me finish this one and then we'll go to that. Okay. Okay. Right now, the next thing here I'm going to do is you can see here, I always like to divide my screen into two so that I will not continue zooming all the time. So you can see this is the beam I want to detail. Okay. Or I can pick any one here among this. If I pick this one, it's very long before I can finish detailing the concept. It's good, but it's just all you need is just the concept. You get it. It's just the concept behind detailing. But I'll most likely detail this and then detail this one also. So if you know how to detail this one, it's the same concept on how to detail any other continuous beam. Or we have simply supported beam, we have continuous beams, we have cantilever beams. Okay, so whatever, once you are able to understand the concept behind the detailing, you know, this is not design. We are not designing right now, we are just doing detailing. All right, so now this beam, if you check the depth, you can see is 450 already. If you check the width of this column here is 230 already. So they are all similar. Is a 230 by 450 beam. The only thing we need to change is the spans of this beam to suit this one, because it's not the same with this. Okay, so what I'm going to do now is I will just use my offsets and I will type 1230, and then I will offset this way. Now you can see my 1230 stops here. This is, don't worry about this. I'm going to explain this later on. So I will use what we call stretch, X for stretch, and I'm going to stretch this beam . Good. So now here, all right, I'm going to delete this annotation here, this dimension here, because this is not the original dimension. Then here is 4 meters. Okay, so I will offset, enter, and I will type 4 meters. Okay, so very, very close to this. So I will stretch again. Yeah, good. So let me take this dimension over again. DLI. Okay. Sorry. Size. I hope you are following.
Yeah,
Okay,
I'm
this one
following
is
you.
this
Just
one is
that.
not important. I'm just trying to arrange something here, not like it's
Okay, so but the issue is your network is breaking sometimes. It will break and come back, break and
no
come back.
problem.
I
It's
hope
not,
by the time you send,
no
if
problem,
you
no
send
problem.
me, if you send me the video, it won't break now.
No problem. It's not a problem. It's recording. It's recording. Don't worry, it's
Okay.
recording. Yeah. I'm recording it. I'm recording it. Don't worry. I don't have time to start going through these settings right now. Let me just. Okay. So you can see that I have successfully rearranged this beam to look exactly as this one is. Now, but there are things I did not explain, okay, which I'm going to explain to you right now. You can see here we have this is the top bar here, which is 2y1625. This is another top bar. This is a different span, as you can see, 1230. This is another different span of 4 meters. You know, like I said, this is not a design, this is detailing that we're doing right now. Yes, your design would tell you to provide top bar, so number of top bar, whether 2 numbers of top bar or 3 numbers of top bar. Your design will tell you at a particular span. You know, it will give you each of those beam with its span. Okay. Now, on our beam, this particular beam now, which is beam 5. Okay, this beam 5, this is the span, this is the other span. It has 2 spans. Okay, now on our span 1 or span A, or whichever way you want to put it, this first span here is 1230. The second span here is actually 4 meters. Now your design will tell you what number of reinforcement you should provide. Now you can see here it's telling us that on this span here that you have 3y16. Okay, now you can see the reinforcement that started from here is the reinforcement that continues to this other span, because if you add up this entire span, this is around 5 meters 230 mm. Okay, are you there?
I'm there. I'm with you.
Okay, the network is actually breaking. So that is how we were able to come about this particular reinforcement. Now, like I said, the reinforcement comes from your design. Oh God, how do I put this for you to relate better? I know very well that you are already confused. I'm just thinking of a way to put it better for you. Okay, what do I do? Okay, let me just arrange all of this first properly. Then we'll come back to the better way for me to explain this. Now, you can see this one comes with how many span? It comes with 1, 2, 3, 4. 4 different span. So I will just pick.
Which one, please?
This beam 2 here, beam 2. Look at it. 1, 2, 3.
Okay, beam
4.
2. Okay.
I will check which one has up to 4 span here. I have 1, 2, 3, 4. So let me copy this. Now, one thing you should notice that on beams, we have the compression, we have the tension. Okay, the compression is at the top, the tension is actually at the bottom. Okay, so these are the points you need to actually take note of. Now, there are beams that comes singly reinforced. There are beams that comes doubly reinforced. It depends on the loading that is actually acting on that beam. But right now, the English I'm speaking now is based on the design. Okay, so I would have loved you to enroll for RCD 2000. There I can explain deeply how that you can come about some of this design. It's more like a manual kind of a design. I can give you much more insight on it, because right now what we are doing is just the detailing of what our design has actually given us already.
Given us already. Okay.
You are getting it. So we are
Yeah.
just detailing what our design has already given us already. So yeah, that's the detailing we are doing right now. So and I'm just assuming whatever all these values for us. That's just what I'm assuming. But let me come to my prota detail and see a particular reinforcement there that was provided for. Then maybe we'll adopt one of it. But let's come back here. Let me arrange these spans first, and then I'm going to rescale this to its original scale. Let me see what is the width from here to here. The same 5. Okay. Well, rescale this. I'll type 230 divided by 538, I think. Yeah, so I have rescaled that to its original scale. Then I'll move this, place it here. So let me confirm the dimension here, if it's correct. Why is it always exceeding it with 1 mm? Let's see. 3016, no. 3015 divided by 3016.
That's a mistake.
It's supposed to be the other way around. Oh, I'm always making this mistake. I don't know. 3016 divided by 30. Am I correct now? Okay. I've made it worse. It's now exceeding with 2 mm. Okay. Oh yeah, I'll get it now. Supposed to be 3015 divided by 3017. This is how it should be. Exactly, it's correct now. Okay. So I will take off all of these dimensions that are on this. All right. So I'm going to check what's the first span here. This is the beam, right? This is the beam from here now to this place. Now look at the first span here. It's 2730. That is what I'm going to do. I will offset 2730. And then I will stretch. I will set the same span. Don't worry, maybe I have to even take it manually, sir, so that instead of even stretching from an existing one, because seems like we are not getting this one. I'm not sure if you are getting it. I'm feeling it strongly in my heart that you're not getting it strong. Okay. I don't know if all the span is the same or okay. Same for that particular beam. Okay, so let me take this measurement now. So I have this beam and all the spans are actually the same. Don't worry, I'm going to take it manually. I'm going to take one of these beam manually too, so that you will understand better. I'm going to do one of it manually so that you understand it much more better, because the way I'm explaining now, I'm feeling it strongly that you're not getting it. So this is it. Then the links, depending on the spacing of the links based on your design. So based on this design, the links is actually 200. Now, if you take this span now, 2,730, and then you divide it by 200, you are going to have around 14. So you can do that manually. All you need to do is, if you take these two values, 2 and 7, okay, 27. So you just approximate this to 28. Divide 28 by 2 is going to give you 14. So that's how to get it very fast. So punch it in your calculator so that you get it right. Because whatever you're going to get from 2730 is going to give you a value of probably 13 point something. So approximately is going to be 14. So you do that manually and check, confirm what I'm telling you. So that's the easiest way to get this divide by 200. You can see it's 13.65. I hope you are confirming what I'm doing. So 13,
yes, 13.65.
Yes, so approximately is 14. So I'm just trying to tell you the best way to get this. Like for this 44 meters now, which is 4,000. This 40, take the first two values, 4 and 0. Now divide it by 2. It's going to give you 20. That's how you get this. For this is 12. Just divide 12 by 2. It's going to give you 6. If you say 1,230, you are going to be having, I think you're going to be having 6 point something. It's not going to be up to 6.5. It's not going to be up to that. It's not going to be up to that. So all you need to do is just to, but whenever you're having a whole number and you're having an even number, okay? So you just approximate it to an even number. I think even number are numbers that can be divided by 2, right? Am I correct?
Yes, yeah. You are correct.
1230. So divided by 200, you can see I'm having 6.15. So it's approximately 6. So that's how to get it. Okay, very fast without punching your calculator. So all you need to do here now is to just change this value now. This is now 28, which is 14 here. Here is also 14. Here is also 14. And then here is also 14. So it's at 200 spacing. That is your links, okay? While your reinforcement here, we have 2y16. These numbers, these are actually numbering, okay? So I'm going to take one now. I will take it. And then this is the cross section. If you take the cross section here, don't worry, I'll come back to explain. I will do it manually and give you a more insight on what I'm doing so that you understand it better, because I'm very sure you're not getting it right now. So I will soon end this section and take you through a better one that you understand better. So what? You said something?
Yeah, I said okay, thank you.
Okay. Look at this beam now. You can see this one. If you cut this is more like an L beam, which is beam 5 here is an L beam. But at least I'm sure you have gotten little something here. Beam 5 here, sorry, this is beam 5. beam 5 here, you can see the shape here. It comes in form of an L. Is that correct? If you check the edge here, is this not an L shape? So this is
There's
an
an
L
L shape.
beam, yes. So it's going to look like this. So while this other beam, which is beam 2, you know this one is beam 2. This is beam 2. This beam 2 here, you can see here, you know, the beam starts from here to this place. Is that correct?
Yes.
Now, if you look at this shape here, is actually the end point you're going to check. Here, you can see this is in form of like a T. Is that correct? So
Yes,
this
yes.
is actually going to be a T-beam. So the cross section here, this is when you are doing your detailing manually. The cross section here is supposed to look like a T shape. So I'll copy a cross section that looks in form of a T and bring it there. I want this section to be over before I start a new drawing for you. So it's going to be in this shape. So this beam will have a cross section like this. This other beam will have a cross section like this. Do you get it?
Yeah, I'm following.
Exactly. So only thing I need to do is just to rescale this also to bring it to its original scale. This is SC. $230 divided by 720, 740. Okay, perfect. So this one also, I will scale this. One 737. $230, 1737. All right, good. So I have just like 16 minutes to, I just want to exhaust this time first, then we'll go into detailing it manually. All right.
Okay, hello?
Yes, I'm with you.
Okay, so if I get what you are doing, what you do is, if you want to draw out a new beam, you offset from the last, from this red line, you offset the span that you want to do. After offsetting it, you now stretch the edge of the other beam to come and meet the new offset.
Yes, you either stretch it to be smaller if the one you are trying to detail now is smaller, or you stretch it to be bigger to suit whatever span you want to achieve. So that's just what I was doing then. But by the time you go through the video, you're going to understand it much better. Because I believe the network has been breaking. There are some
yes. Why you were stretching it, the network was breaking.
Exactly.
So I didn't see how you
it's not going to be a problem. I will send you the video as soon as I finish. Immediately I will forward it to you immediately, so that
okay.
Yes, by the time you start practicing on your own, you understand it better. So that's just, you can see all I did was to offset because it's from center to center. Okay, you can see this is from center. This is center to center. Okay, this is also from this center of this beam to this center. Sorry, from that center of this column to the center of this particular column. So that's just what I did. Okay, so it's just offsetting and then stretching, offset and stretch, then changing the values, because this beam now, based on the design we did for this one, may not be 3Y16 here. It may be 2Y16, whatever the result of our design is telling us. So I will just change it to 2, for example. If the design is telling us I should use 2. Then here, the design may be telling us to use 3 here. And then all I need to do is just to change it to 3, for example. You get the point. And then you can see for this reinforcement here is starting from here down to this point. Okay, so based on this design, it's telling us that it is 3y16. So let's say our design, the present design is telling us to use 2y16. All I need to do is just to change this value to 2. And then how to get the links, I explained that to you, that all you need to do is just to take the first two values that you see, divide it by 2 is going to give you that value, because our spacing is 200 spacing. But it changes. If you are using a spacing of 250, you cannot adopt the same this thing I used just now. So you can, so depending on whatever your spacing is for your links, okay? So you just play around with it and you get the value right.
Okay, you also mentioned that the top bars are for compression, while the down bars are for tension.
Yes.
Is it like that is it a constant thing for all beams?
Yes, now your top take care of the compression, your bottom takes care of the tensile stress. Okay, yes, that's why I kept on telling you to lay your hands on Victor Oyenuga's book. Yes, you understand all that I was trying to say, but that is actually in design. Okay, in order to understand where you are taking care of the compression, the tension, and all that, all those grammar, you understand it better by the time you lay your hands on that book. Okay, or if possible, whenever you have time, you can go through this RCD 2000. Honestly, you have a very deep insight. I have made so much emphasis on that software. It's very, 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 in short, it's the best for any beginner, honestly. Once you understand it very well. Yes, once you understand it very well.
It's a textbook, Abi.
No, it's a software. RCD 2000 is a software. Reinforced concrete, simplified reinforced concrete design is a book. This by the same author. You get it?
Okay.
Yeah, by the same author. The RCD 2000 is owned by the same author. The simplified reinforced concrete design is a book, while the RCD 2000 is a software owned by the same author. Okay, it's a bit old, but honestly is actually very good, because you are going to have deep insights on design. You understand how the structural members, how they behave, how the loadings are being distributed down from the slab to the beam to the column, down to the foundation. You are going to really understand all of that. You are going to see how you are distributing some of those loads manually by yourself. Is very, very, very educative, honestly. So this session is about to end. I'm going to continue with you in the next session. I'm going to be showing you how to come about the detailing manually on AutoCAD. This time around, I'm not going to be stretching from anything. I'm just going to be drafting it manually the way it should be. All right.
All right, thank you.
Ended this right now.